Welcome to my channel. Your tutor Mariam is here. It's the ninth video of Introductory Physics 1 and the fifth video that I'm going to talk about the motion. That is the second subject of Introductory Physics 1. In this video, I'm going to solve a couple of examples and show you how to calculate the velocity and acceleration based on the motion equation. If you are new to Introductory Physics 1, hit the subscribe button and like for more. You ready? Let's get started. This problem asks me to calculate the average velocity based on the motion equation right here, right? So we know average velocity gonna be delta x over delta t, right? So for t equal to 2 seconds, I have x equal to 3 times 2 to a square plus 4 times 2 plus 1, right? Which is equal to 3 times 4 plus 8 plus 1, which is equal to 21 meter, correct? And then for t equal to 3 seconds, I have x equal to 3 times 3 square plus 4 times 3 plus 1, which is equal to 3 times 9, 12 plus 1, which is equal to 40 meter, correct? So now my v is equal to delta x over delta t, which is equal to 40 minus 21, and then 3 minus 2, that is equal to 90 meter per second, right? How about part B? So here is asked me to calculate velocity or instantaneous velocity. So whenever you see velocity in your problem and you only see at a specific time, like here it's t equal to 3 seconds, that means usually it means you should calculate the instantaneous velocity. So for doing that, the instantaneous velocity gonna be vs equal to derivative of x respect to time, right? So I'm gonna take the derivative of motion equation, which is 3 t squared 4t plus 1, right? Is equal to 60 plus 4. And now I'm going to substitute t as a 3 second right here, right? So it's going to be 6 times 3 plus 4 is equal to 22 meter per second. So here for average velocity, I need to calculate the delta x over delta t. And for the instantaneous velocity, I'm going to take the derivative of motion equation, okay? Let's look at the second question. In this problem, I need to calculate the average acceleration at t equal to 1 second and 2 seconds. And here I have the velocity equation, okay? So for average acceleration, I have a equal to delta v over delta t. So it's kind of similar to average velocity. In average velocity, we're dealing with delta x over delta t. And for the average acceleration, we're gonna work with the average velocity over time, okay? So now for t equal to 1, my v gonna be 2 times 1 plus 3 to 1 plus 5, which is equal to 10 meter per second, correct? And what about t equal to 2 seconds? My v gonna be 2 times 2 square, 3 times 2 plus 5, that is equal to 19 meter per second, right? So my a acceleration, average acceleration, gonna be delta v over delta t, which is equal to 19 minus 10, and then 2 minus 1, which is equal to 9 meter per second square, right? So how about the instantaneous velocity, part B? So this is for part A, and this is for part B. So for the instantaneous acceleration, A is going to be derivative of v over t, correct? So it's going to be d dt, and then it's going to be 2 square 3t plus 5. And this derivative going to be 4t plus 3, which is equal to 4. And then here I have time as 4 seconds plus 3. And the answer going to be 19 meter per second square, right? Let's look at the next question. So in this problem, I have the acceleration equation, and now I need to calculate the instantaneous velocity, right, for part A. So based on the equation I wrote in the previous slide, my A gonna be dv over dt, right? So if I'm gonna calculate dv at this time, is gonna be a times dt, right? And then for calculating this type of the problems, I need to take the integration, right? So it's gonna be dv and then a dt, right? So at this time I have v, right? And then it's gonna be a dt. So based on this equation right here, I need to take the integration of a in order to calculate the velocity, right? Let's see how I'm going to do that. So it's going to be v, my equation as a going to be 2t plus 1. So I'm substituting the a from the problem here, and then I have t, correct? And now I have 2t times dt plus 1 dt, right? So if I'm going to take the integration, it's going to be 2, and then it's going to be t, right? So these two cancel out, and I'm going to get t2 plus t, right? So that's the equation I have for velocity. And then it's asked me to calculate the instantaneous velocity of car at t equal to 2 seconds. So I have the equation for v, and I need to substitute t here. So for t equal to 2 seconds, if t equal to 2, then my v gonna be 2 square plus 2, which is equal to 6 meter per second, right? So how about the displacement at t equal to 1 and 2 seconds, right? So same things, if I have the velocity, I can take the integration of that equation and then calculate the velocity, calculate the displacement, right? So right here, I have the velocity equation. Now I need to take the integration of this. So my x gonna be the integration of v dt, right? So my v here is gonna be t2 plus t dt, right? Which is gonna be t2 dt plus t dt, correct? So it's gonna be over third and then plus 2, correct? So for t equal to 1, my displacement x here gonna be 1 over 3 plus 1 over 2, right? Which is equal to 6. 2 plus 3, which is 5 over 6, correct? And for t equal to 2 seconds, my x gonna be 2 to the third, and then 2 square over 2, right? The answer gonna be 14 over 3. Then displacement gonna be minus 5, 6, which is equal to 23 over 6 meter. And this is gonna be my final answer. I hope this video helped you to understand the subjects better. If you like my video, please hit the like button and I'll see you in the next video.